This is the screencast for section 10.2, example 3. We're going to look at some vector operations. First of all, to redefine from pre-calc what the unit vector is the vector v divided by the magnitude of its vector. Should be a vector of magnitude 1. So a unit vector is of magnitude 1 unit vector. Can be any direction, just has to be a length of 1. Now then some more definitions. If we have u is u1 and comma u2, so x comma y, and v is v1 v2 for x comma y. If we have the sum of those vectors, we add their x coordinates comma adding their y coordinates. The product by a scalar would be multiply both the x and y coordinate by the scalar. The opposite of the vector is how we subtract, so we really add a negative vector, and that's just easier to see with some of these pictures. So here's our scalar example down here. So if I have u, here's 2u, twice the magnitude. If I have 1/2 u and negative 2u, see, look at that, the negative one is going backwards, but also 4 times as long, because 1/2 getting to 2 is 4 times as long. Now adding vectors, here's u, and then at the head of u we put the tail of v, and then the u plus v vector would be this one, resulting in that same point. Now these three properties will also lead you to a few other conclusions that we can make here. I'll let you look those over on your own. Example 3 here, let's perform the operations on vectors. So u is going to be the vector -1, 3, and v is going to be the vector 4, 7. So we want to find the following. We're going to do 2u plus 3v. So 2 times the magnitude of u, so u is now going to be twice as long, which means I want 2 times the vector u plus 3 times the vector 4, 7. So not only am I stretching out those two vectors, I'm then adding them together. Well, 2 times -1, 3 is going to be -2, 2 times -1, and then 2 times 3 is 6. So now this vector, -2, 6, is twice as long as -1, 3. 3 times the vector v, so we have 3 times 4, which is 12, 3 times 7, which is 21. Now we have to add those together. Remember, we add the x coordinates, so -2 plus 12 is 10, and then 6 plus 21 is 27. So if we stretch out the u vector to be twice as long and add 3 times the length of the v vector, we'll get 1027 as our vector. So starting at the origin, ending at the point 10, 27. And maybe you want to draw yourself a little sketch of what happened right over here on the side. B, u minus v. Well, remember, we don't do subtraction of vectors, we actually do adding a negative vector. So I write out u minus v, but really what I'm doing is I'm taking -1 plus -4, so -5, and then 3 plus -7, which is the same as subtraction, I get it, -4. The only reason why we do plus is because then you can see in the picture one of them is going to go one direction, the other one's going to go back the other direction. Again, try drawing yourself a little picture of what that looks like to get the picture to match up with the math. Part C, half of the magnitude of u. Alright, well, half of the vector u would be 1/2 comma 3/2. So let's find the magnitude of that. So I took the square root of a squared plus b squared, and I get the square root of 1/4 plus 9/4, so 1/2 times the square root of 10, which means then the magnitude of u is square root 10. If the magnitude of a vector half the length of u is 1/2 square root 10, that means the magnitude or length of vector u then was square root 10. Then now try problem number 21. Find A, the component form, and then B, the magnitude of the vector. Okay, so 2 times u, so that's going to be 2 times and then 3 comma -2, minus 3 times the vector v. So here I'm going to distribute the 2. That's going to be 6, -4. And then remember, I'm adding, really, this vector, which is now going to be 6, comma 15, -15. Now adding those two, I add their x coordinates, add their y coordinates. That is the component form of twice u minus 3 times v. Now part B, the magnitude of that vector. So I'm really trying to find the magnitude of 2u minus 3v. Well, I already know what that vector is. So I'm just going to take the square root of the a coordinate squared plus the b coordinate squared, or x squared plus y squared, the distance, and I get the square root of 505.